Okay, let's see this problem now. The problem is prove that two distinct lines cannot have more than one point in common. So it basically means that if there are two distinct lines and they cross each other, then the crossing or the intersection or the common point can only be unique one point. But before we actually know how can we prove this, so we just go with the opposite idea. We just assume that the contrary is right. So we are saying that let us assume that more than one point can be common. Not just one point, but 2 points, 3 points. More than one points are possible. So more than one point can be common between two lines. Now if you assume that, then the immediate idea is, okay, there are 2 points A and B, and these 2 points are common between the two lines. Now I can't draw the diagram for this because it is just not possible. But why draw the diagram? We can immediately get to this because this is actually against the axiom. The axiom 5.1 stated after the fifth postulate that through any two distinct points, only one line can pass. We know that if there are any two lines, any 2 points, then through these 2 points only unique line can pass. So if there are 2 points A and B, then two lines cannot pass through them. Only one line can pass through them. As a result of this assumption was wrong. So we come to the conclusion that if there are two lines, only one point can be common between them. Let's see the next problem. Is the following statement a direct consequence of Euclid's fifth postulate? What statement? See this, there exists a pair of straight lines that are everywhere equidistant from one another. Everywhere equidistant, so the perpendicular distance between the two lines is constant. So basically the two lines are parallel to each other. This is what is being said. Let's see this. I will draw a rough diagram of this. So there are two lines. This is the intersecting line or transversal line. The two lines and the transversal line make interior angles A, here it is B, C and D. If the two lines are parallel to each other, we know Euclid did not talk about this. We will come to what Euclid is saying and we will prove using Euclidean geometry. But before that, we already know. What we know, let's see this. We already know that if the lines are parallel, A plus B is equal to 180 degree and C plus D is equal to 180 degree. Again, 180 degree is also something that Euclid did not know about because at that time the angle was not measured in degrees at all. So Euclid had no idea about what is 180 degrees. But we are saying what is our knowledge right now in these days. We already know this. Supposedly this line was slightly bent on this side. The upper line is slightly bent on this side. How? Let's see. See, it is bent like this. And you see the faint line behind this line was the original line. But if the line is bent slightly, then you clearly see the angle A must have been reduced slightly. Angle A has reduced and angle C has slightly increased. So what was B? B has not changed. So but angle C has slightly increased. So C plus D would be now greater than 180 degree and A plus B would be less than 180 degree. A plus B is less than 180 degree and C plus D is greater than 180 degree. This is it, this is happening. And this is what Euclid said in the fifth postulate. Euclid said that if the lines are such that there are two lines and there is a transversal line, then the side on which the addition of interior angles is lesser is where the two lines will meet. You produce the lines here, they will meet here. And the side where the addition of interior angles is greater than 180 degree. Euclid did not say 180 degree, Euclid said greater than twice of right angles or two right angles. Which means the same thing. One right angle is 90 degree, two right angles is 180 degree. If these two angles sum is greater than 180, then this will go on moving apart from each other. So the lines will be going apart in this direction. As a result of this, the lines will never meet. But here what are we doing is we are talking about a possibility where on one side the interior angle sum is less than 180 degree, on the other side the interior angle sum is greater than 180 degree. What if the interior angle sum is not greater or lesser on any side. What if they are equal? So what will happen? Let's see. Again, if we had the same line here, what if the lines are such that, see how, like this again, then here a plus b is 180 degree and c plus d is also equal to 180 degree. So the line is not bending on this side, nor the other line is bending on this side. There is no side on which the lines are coming closer and there is no side on which the lines are moving apart. So the lines are actually going parallel to each other. And if the lines are going parallel to each other, then the distance between them will be equal everywhere. The distance between these two lines will be equal everywhere. And the distance is equidistant from one another. That is exactly what Euclid said in the fifth postulate. In the fifth postulate, Euclid is talking about where would the lines meet. And here the implication or just a fallout of that is we are trying to say when will the lines not meet. So this is really the consequence of Euclid's fifth postulate. Alright, I hope you understood this. Thank you.